Okay, so till last class, do you have any doubt? Anyone? I hope everything is clear up to the last class, right? So if you have any doubt, you can ask now, and we'll be waiting for maybe 1 more minute for some other more people to join, and then we will start. So in the meantime, if you have any doubt, you can ask, or if you have understood, just you can give me the feedback that we have. Yes, we have understood up to last class. Then I'll know with what is your status, right? Anyone may unmute and let me know whether you have understood the last class or not. Okay, so no one wants to. Okay, so whatever be it. So I believe all of you have gone through your class test 1 March. So are you happy with your performance? Are you all happy with your performance? Or you think that you need to improve?
Need to improve.
Yeah, definitely people have to need to improve also. Okay, and that degree of freedom, that kind of problem, you try solving some more. Okay, because what happens, as I have previously also discussed in the class. So if you just go through whatever I'm just discussing, I am showing, I am solving the problems for you, then they look very easy. Okay, but sometimes what happens, if you don't practice, maybe some of the links, numbering the links and so on. Okay, that kind of small steps you may make mistake in the small steps. Okay, so that's why practicing them is also important. And one mistake that we have seen in your cases, most of you are not drawing the diagrams. So in most of the engineering and science like subjects, so drawing proper level diagram, it's very important, okay, to justify your answer. And there are some questions just like the degree of freedom. There you must have to draw that particular diagram. Okay, the diagram quality, it may not be exactly similar, but all the links in their relative positions, it should be there and all. Okay, and whatever link number you have written, suppose n equal to 9, 10, so they has to be numbered, they have to be numbered in that particular diagram, so that the evaluator knows, that means yes, he has not just guessed it and written it. Okay, n equal to 9, 10 or whatever, but he or she knows about it. Okay, so that is the thing. And similarly, suppose if you have drawn the diagram and if you have shown, suppose there were 12 links, and up to 11th link you have shown it properly in the diagram. Suppose by some mistake or you have forgotten, whatever be it, maybe the one last link you have not numbered and you have not shown. So if you draw the diagram and the other links, the other 11 links or 9, whatever, so that particular link, if you show it properly, show them properly, then there is a chance that then there you will definitely get some more state marks. Okay, otherwise if you just blindly write it, then there is no scope for giving state marks also actually. Okay, and so these are things. So now if you have still any doubt, you can, anyone can ask, and otherwise we will continue with the today's session, and you can just let me know whether we should continue or you are going to ask some question from previous classes. Okay, we'll move ahead then. So up to the last class, so already why gear drives are used, what are the peculiarity of them, okay, how basically gear is working, all those things we have discussed. Then the different nomenclatures of gear, okay, different types of gears already we have discussed, and different gear terminologies we have discussed. Okay, we have discussed about backlash, it's whether it is a good thing or bad, whether it is required or not. Okay, what happens, what is the effect of backlash, etc. So all those things we have already discussed in the previous class. We have also seen how basically the size determines the torque as well as the speed, how they are related. Okay, in case of two gears which are in proper mesh, so all those things we have discussed. Similarly, what is velocity ratio, how the number of teeth, the size, that is the diameter or radius, in terms of diameter or radius, or the velocity ratio, how they are related, and all those things we have discussed. So today we are going to discuss another very important concept, that is basically known as the law of gearing. So what is this law of gearing? So what does basically it states? So see, whenever we're talking about using a particular pair of gear, okay, So we want to do certain tasks. Okay, we want to accomplish certain tasks, and in that particular case, we already know always this gear drive they are associated with transfer of motion. Okay, and ultimately some velocity ratio. That means if you are talking just like in the last class we have discussed about velocity ratio. So that velocity ratio is of that particular drive also is important. So whatever for whatever purpose we have utilized that particular gear drive. Okay, so to accomplish that particular task, suppose a certain velocity ratio is desired, depending on whether you are stepping up, that is, you are increasing the velocity or decreasing the velocity by the application of proper pair of gear wheel. Okay, but the thing is, constant velocity ratio is desired. So now, how to make sure that basically we are going to get the constant velocity ratio for a particular gear drive? So this law of gearing basically gives you that particular condition which should be fulfilled. So now what does it state? So for constant angular velocity ratio of the two gears which are in mass, the common normal at the point of contact of the two mating teeth, it must pass through the pitch point. Okay, that means if you look at this particular figure, don't get frightened by looking at this particular figure. So this is why, if you know what are the things we are showing here, okay, this figure is very easy figure only. Okay, so basically by these two figures, so figure body one, this body one and body two, with these two bodies basically we are going to discuss. We are showing the two bodies one and two, they are representing the portion of the two gear teeth which are in mesh. Okay, so like arbitrary kind of shape we are just saying, so it's a kind of the portion of the two gear teeth as if they are in mesh. Okay, two different two bodies. Okay, and we also know in case of our gears, so the teeth portion from both the mating gears, they are actually the teeth are in contact. Okay, and there is a point we know that that is basically already from our previous discussion about, we already know about pitch point and all. Okay, so that pitch point also we already know. So now what does it state? So if we expect if we think that we are talking of this particular angular velocity ratio, because we know that these gears they are basically like rotating element actually. Okay, so whenever our expectation is, whenever suppose gear A, if this is the driver, whenever it rotates, so depending on whatever is the arrangement of it, so with a particular constant velocity ratio, actually gear B or gear number 2, it should also get that particular motion. So that is what is our intention. So in that particular case, the common normal at the pitch point of contact of the two mating teeth, it must pass through the pitch point. So if this is the pitch point, then the common normal to both the teeth, okay, this is n, and it represents the common normal. Common normal means it is normal to both body 1 and body 2. Okay, similarly common tangent means this tt, it represents common tangent. You can see, suppose if this is the curvature of this particular body at this particular position, similarly if this is the case for this particular body, so this line, this tt line, okay, it touches them at a particular single point, both the bodies, so it's a common normal to both body A and body 1 and body 2. Similarly, the 90-degree to the common tangent itself is nothing but common normal. Okay, so this particular is common normal to it. So actually this particular law states the condition which must be fulfilled by gear to profile so as to maintain a constant angular velocity ratio between the two gears, and that is very important, we already know. So now we are going to analyze this particular okay, this particular condition. Now for that we are going to use this particular figure only, this figure, so which represents two bodies. Okay, body A, body 1, body 2, and by this body 1 and body 2 we are representing the portion of the two gear teeth which are in mesh. Okay, now as if gear this body 1, as if it is rotating about this okay, center A. Similarly, as if for this particular body 2, center of rotation is as if this particular point B. Okay, so that is the case. Okay, next we are going to, that means if this is the body which is rotating with an angular velocity omega 1 in clockwise direction, then the angular velocity has connected. So this per body 2, it is moving in the anti-clockwise direction, and suppose its angular velocity is omega 2. Okay, and this is the point of contact, this is the point of contact between the two bodies. Okay, so this point, contact point, you can see here. Okay, so this is the point of contact, and we can assume as if point of contact is C, CD, C is as we are saying, it is the same point, but we can assume as if C is the point of contact for this particular body, which is on this particular point, okay, and D is there on this particular body. But actually, C and D, both of them are coincident point. That means they are on the same point. Okay, it is the same point. But we are considering as if for body A, it is the point is C, as if for body B, that is second body, it is point D. Okay. Next, we know in general the velocity. Okay, we'll be discussing in this subsequent figure. So already we have discussed omega 1. It is the instantaneous angular velocity of gear 1. So same direction, omega 2 instantaneous angular velocity of the gear 2, which in this point we are talking about. Okay, and v suffix d of D, point D. Okay, actually C and D, actually they are the same coincident point. Okay, which is the point of suffix C or V suffix D. We already know, like V equal to R omega. That particular expression you already know. We have also previously also used it. Okay, to omega. Omega is the angular velocity. R is basically the normally that radial distance we are talking about. For VC, how we can write that V equal to R omega? Omega, there is no problem. Omega particular one is velocity, body 2 is the angular velocity. And if I now this point, so from say we know that body A is body 1 is rotating at this point to the point A, and body 2 it is about this particular point B. So AC, if we connect that particular point C point with A, that is AC, that is the radial distance for this. So V equal to R omega, it becomes R is this much. AC is the radial distance value R. Okay, so and omega is omega 1. Okay, and what will be the direction of VC? So this direction of VC will be always to A. Okay, or at an
Sir,
alpha. Yes.
sir, 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 voice is not clear.
Okay, is it same problem for others?
Sir,
Others,
your
are
voice is
you?
not
If
clear.
people can.
Sir, it stuck
Okay,
sometimes.
okay. For others,
Not
I am
constant.
asking. Sometimes it stuck, right? But it is understandable.
Sir, if we miss like one or two lines, then it's not understandable, sir. Because we missed the link now, sir.
Okay,
Sir, your
I'll
voice
repeat
is not
then. Okay,
clear.
don't worry.
Not coming clear.
Okay, let me change the. Okay, I have changed to mobile data. Is it voice is audible properly now?
Yes, sir.
Okay, I think the Wi-Fi is fluctuating then. Okay, now it should be good. Okay, I'm using the mobile data now. Okay, so I'll just repeat once again. So these two bodies, okay, so it is omega 1 is the angular velocity per body 1, omega 2 is the angular velocity per body 2. Okay, so they are here at this, they're meeting here at this point, and C is the point which is on body 1, and we are considering the point of where both the body meets, that is the D for body 2. But actually C and D, actually they are the same point, but for just for our analysis purpose, we are designating as if C is on body A, body 1, and D point is on body 2. Okay, and so omega 1 and omega 2 already we have discussed. So V suffix C and V suffix D we have considered. So Vc is the linear velocity for C, V suffix D it is the linear velocity for D. And now how we can get this linear velocity? We know that V equal to R omega, that expression we already know, okay, from your engineering mechanics knowledge, as well as we have already used this expression here also. So now R omega means omega is the angular velocity, there is no problem for C point. The C is located on body 1, so it will be omega 1. For D it will be omega 2. So how to get that R? So R is nothing but the radial distance. So now if we connect this particular point C with this particular center, so it becomes our radial distance for this case. We can consider R as AC. This much distance as R for body A, body 1, and this much distance, that is BC, if we connect them, it will be the R for your the radial distance for D. Okay, body 2. Okay, so we can write VC equal to omega 1 into AC, VD equal to omega 2 into BD. Now, what will be the direction? So these are, so we already know velocity is a vector. So its direction is perpendicular to AC for VC. So it is always perpendicular to this particular body at AC. Okay, so this VC is perpendicular to this AC. Okay, similarly, VD is perpendicular to BD. Understood? Or with respect to the normal, common normal, I'll be going to this particular figure, same figure, but in a bigger manner it is there. So with respect to the common normal, as if VC is making an angle alpha, this angle, and VD, which is perpendicular to BD, it is making an angle beta. Understood? So next, this is the common normal. So this becomes 90 degree to common normal is nothing but the common tangent. And what we have done, we have
Sir,
just connected. Yes,
sir,
yes, Samim.
hello.
Yes, Samim. I think it's
Sir, your
your
voice is
network.
not clear.
I think your network problem might also be there, because others, I think for them it is not that much problem. You can you move to a better place with better network reception, somewhat better network reception. I think others now it is good, right? Because I have already sent to another better network, mobile network. Can anyone else, maybe Hitesh or Tapas or anyone else, can let me know? Because only if only one,
Yes,
it
sir.
is
It's clear,
problem
sir.
is only one. Yes. So Samim, so it's better come to a place with better network reception. Okay. Okay. I'm coming now. Okay. So now after that, this particular, we have just joined that particular center point for body one and body two AB. Okay. And now I think it should be this particular figure should make sense to you people. Okay. What are the elements we have? Just let me know. Because otherwise, if you just look at this particular figure, you may think that, okay, what are the things? Just everything it is drawing this line, that direction, and all. I think now it should be clear. Everything we have just made it. Yes. Can anyone let me know whether this clear figure is clear or not? Because the elements already everything we have discussed.
Yes, sir.
Okay, thank you. So now rest is somewhat simple only. So what we can do now, if the curved surface of the teeth of the both the gears, they have to remain in contact, and this contact is very necessary. Otherwise, if the contact is broken between gear 1 and gear 2, the teeth we are talking about, okay, then there will not be any motion transfer and all, and we cannot expect any movement in that particular. Suppose when driver is rotating, we cannot expect any motion in the driven. So the contact has to be there, okay. And in that particular case, okay, if the curved surfaces of the two teeth of the two mating gears, they have to remain in contact. One surface it may slide relative to the other along the common tangent. So this way along the tangent, okay, if you consider, suppose this body one is moving in the clockwise direction, rotating in the clockwise direction. So if it slides along the common tangent, this particular direction, okay, then it's okay. Okay, but what we don't want, see, if they are rotating in this particular along this sliding along this particular direction in the common tangent direction, there is no problem, we expect that. But we don't want any relative motion between the surfaces along the common normal. Common normal is this direction. Okay, so we expect we want this way along this common tangent tt, this direction, they will slide, but we don't want they should move along this particular direction, common normal direction. Why? Because if they slides along the tt direction, there will not be any separation and all, so it will work smoothly. And there will be a problem if they move along the relatively along the common normal direction, there will be a problem, and that problem will be the problem of penetration. Okay, if they have the tendency of moving in this particular direction, common normal direction, then body 1 may try to penetrate on body 2, and thus we know we are representing the teeth only. So one teeth from the mating gear, if it tries to go inside the another teeth from the another gear which are in mass, then definitely there will be problem. Okay, so the strength of the teeth will be lost. Okay, there may be some crack, etc., or the motion transfer will not take place properly. Okay, so we want motion to be sliding motion to along the common tangent, and we don't want any relative motion along the common normal. So relative motion between in the common normal direction, it should be zero. That means, okay, no motion means zero. Okay, up to this much I believe it is clear, the condition why there should not be any movement in the common normal direction. So that is what we are just going to use. Okay, we are going to find out the velocity along the common normal, and we are going to equate it to zero because we don't want any. Understood?
Sir,
Sir,
can you
if it is
repeat once?
non-zero, then what will happen, sir?
Yes, please, one by one. Khandip, you go first.
Sir, if the common normal is zero, not non-zero, then what will happen?
Yeah, that is what we have said. Common normal, along the common normal direction, if there is any relative motion, okay, then you see two bodies. We are considering suppose two bodies. Then in this direction, you have understood the common normal direction. Okay, this is the common normal direction. So if there is tendency of movement along the common normal direction, then the tendency is to suppose body one is trying to go inside body two. So if body one is trying to go inside or penetrate in the body two, if you consider they are the tooth from the two machine gears, you can consider then that is not an expected result, right? We don't want that one body is trying to penetrate inside the body two. Okay, one teeth is trying to penetrate inside the second teeth. Then the strength from both the like teeth will be like lost. Okay, the gearing arrangement is not going to give you any kind of proper transmission of motion and all. Okay, similarly, if in that way, if the if the teeth gets deformed, once again there will be problem of messing, as well as like loss of efficiency and all. Okay, so those are the problems. So we don't want any the relative motion between the common normal direction, but it should slide along the common tangent direction. Okay, that means if you just try to consider as if this particular body is rotating, there it is rotating about, body one is rotating about point A, and this is the clockwise direction motion. So this way along this slide, it should slide like that. Understood? Now is it clear, Kandip?
Yes, sir.
Okay. Tapos, what was your question? Or whether you are saying you have understood?
Sir, I got my answer, sir.
Okay, okay, thank you. So now we can just get the component of VC. We already know VC is particular this direction. Okay, velocity of linear velocity of C. Similarly, we can get the component of VD along normal. So if from this figure, it will be bigger figure. So see, this is the VC, this is VD, and they are making angle alpha and beta with common normal. So you can get the component of them. So just the component, how to get it? Just taking the VC into cos component, cos of this particular alpha. Okay, so component of VC along NN, VC into cos alpha. Similarly, the component along NN for VD will be VD cos of beta. And what is the, both the components are in the same direction we are considering along the common normal. So we can, if I subtract them, we can get a relative motion between them. Okay, so relative motion along the common normal, just subtracting one from the another, VC cos alpha minus VD cos beta. Now for our analysis purpose, this particular relative motion along common normal, what should be its value? This VC cos alpha minus VD cos beta. Can anyone tell me what should be the value? Numerical value.
Channel, sir.
It should be zero. It should be zero. It means it is the relative motion along NN, and we are saying that there should not be any relative motion. That means this value should be zero, right? Understood? There should not be any velocity, means velocity should be zero. So just we are just now equating them to zero. Okay, the relative velocity along NN, that is the common normal direction, we are just equating to 0, and after that it is just the simplification. V equal to R omega, that is what we have used, omega into AC cos of alpha. Similarly, VD was omega 2 into BD, already you have obtained cos of beta, and from these triangles, that we have made. Okay, so from this triangle we can get the cos of alpha and cos of beta. Okay, both the triangles AP and BFP. So ABFP, this triangle, and AEP, okay, this triangle, so they are actually similar triangle. If you can look properly, okay, this is 90 degree, 90 degree, it is the same angle. Okay, and so basically they are the similar triangle only. Okay, so from there we just have to, like, we are just simplifying them, and what we have obtained ultimately, the ratio of the angular velocities we have obtained, like omega 1 by omega 2 equal to BP by AP. So omega 1 by omega 2 equal to BP, this particular distance, by divided by AP. Okay, so that is what we have obtained. And what does it means? That means the center line AB, this particular center lines A and B, yes, it is divided by this particular point, right? P, it is lying on this particular center line AB. P point is somewhere here, which is lying on AB. Okay, so the center line AB is divided by P by the common normal in the inverse ratio of the angular velocity of the two gases. Why we are saying it is inverse ratio? Because omega, it is omega 1 by omega 2, omega 1 for body A, but it is omega 1 by omega 2 is equal to BP. Mostly it is on from body 2 and by AP from body 2. So it is the inverse ratio we are talking about. Okay, now if a constant angular velocity of both the two gears is desired, so the common normal at the point of contact of the both the teeth, it should pass through this particular point, fixed point P. So that means after analysis we have obtained that particular ratio, and we have seen that actually this P point is important, and this common normal, this one, and it is passing through this particular point, a particular point P. Okay, and that particular point P is nothing but the actually pitch point. Okay, so that is what is the condition, and we have shown it like that. Understood? I hope all of you have understood. Okay, once you understand the figure and the different components of both the velocity components, it's easy only. Okay, I hope all of you have understood. Next, we'll be discussing another thing. Okay, that is the velocity of sliding. So what we have previously discussed, we have said that if the two surfaces, that is the curved surface we are talking about, which are representing the teeth from gear A and gear 1 and gear 2, which are in mass. So if they has to be contact, they has to remain in contact, and that is what is our intention. They should always remain in contact. Otherwise, like, at least some contact should be there. Then only we can expect that some motion transfer, etc., will be there through the transfer of force. Okay. So now in that particular case, in the last section itself, we have seen that one has to have a sliding motion relative to the other along the common tangent. So along the common tangent, it is sliding motion is desired, but along the normal, no motion is desired. Okay, so now just like in the previous case, we have considered the component of VC as well as VD along the common normal. It was the cos component. So normal and tangent, what is the angle between them? It is nothing but the 90 degree. 90 degree to normal is tangent, 90 degree to tangent is normal. Okay, they are always lying at the 90 degree only. Okay, so now if we consider the component of VC along the common tangent, then it will just be the sine component. Just like the previous case, it was the cos component along normal. So now it will be sine component for the velocity. So we are taking the sine component. So it will be component for VC is VC sine alpha. Component for VD along TT, that is the common tangent, is VD sine of beta. So velocity of sliding we can get. So velocity of sliding is the subtracting one from another. We are going to get the sliding velocity or the velocity of sliding. This word is velocity of sliding. Okay, so we can write VC sine of alpha minus VD sine of beta. Now VC and VD already we have obtained R omega, that using the R omega. Okay, so that is omega 1 into AC is VC, omega 2 into BD, R omega. Okay, it is VD. So that those things we have used here. And sine alpha and sine beta, just from the previous figure, we are referring to the same previous figure. And from that particular previous figure, just taking the, I believe all of you already know that some people have curly black hair turn permanently black. Okay, so using that, you can just find out the sine alpha and sine beta, that ratio. Okay, it is EC by AC and FD by BD. And from here, just after simplifying, actually what will happen, so you will get in terms of PC and PD. Okay, and we already know from this particular figure, I have said that this point C and D, they are nothing but the same coincident point. Actually they are the same point. So if I discuss suppose PC and if I say PD, actually the distance is same. I can send it, they are interchangeable. That means PC also I can write like PD, or PD I can write like PC, because C and D are the same point. Okay, that is what we have done. So PC and PD, just we have converted to same thing, PC, or either PD also you can do, no problem. Okay, so after that, what we have obtained, taking common, it is omega 1 plus omega 2 whole into PC. So that is the Laplace simplification. Okay, so now what is that? So omega 1 plus omega 2 is nothing but the sum of the two angular velocities from both the meshing gears multiplied by PC is what? Distance between the pitch point, because P was pitch point and the point of contact. Okay, so if we look at this particular figure, so how to get the sliding velocity for a pair of teeth, gear teeth which are in contact, it will be the summation of angular velocity for both the gears, that is omega 1 plus omega 2 into PC. PC is which distance from pitch point to the point of contact. So this much. Okay. So if you know this, so actually your job is done. Okay. And how generally we can get this PC value? See, C is the extreme point. Okay, mostly the extreme point, and the point of contact. Sometimes it may be that addendum portion or like that. Okay. So ultimately, if you know about the angular velocity of PC, and you can get the velocity of sliding. Understood? Anything only, just coming from the diagram. I hope all of you have understood. Just anyone may let me know.
Sir,
Yes,
your
sir.
voice is not coming clearly.
Okay, thank you. Yes, Kandip, any problem? Okay, so we'll just move ahead to another thing. So in this particular figure, actually we are trying to represent the similar kind of thing only, but in a different manner. So we just want to show the pressure angle in case of our gear. Okay, so here what we are showing, only one teeth which are in mesh from both the meshing gears. So these are the center point. Okay, so this is the center for this gear, and this is the center for this particular gear. So bigger wheel is generally considered as the gear, smaller wheel generally is the pinion. Okay, so if it is rotating in this direction, gear wheel, pinion is rotating in this direction, gear will rotate in this particular direction. Okay, clockwise and anti-clockwise, that will be different. Now here, just like in the previous case we have discussed, so this is the pressure line. Okay, so this is the common tangent that we have. Okay, and this pressure line, okay, it is actually what is the pressure line? Actually this pressure line is passing through, it's a tangent to both this particular base circles. Okay, base circle from this and base circle from this gear. Okay, so whatever is the common tangent, it is there to the base circles of both the meshing gears, that is the pressure line. Okay, that is known as the pressure line. Okay, and already that is the at this particular pitch point, pitch circle, actually this is the common tangent to them. Okay, this is the common tangent direction, and this is the pressure line direction. And what is the pressure line? Actually pressure line is a common tangent to both the base circles from the meshing gears. Okay, so you can see this is the base circle for this gear, this is the base circle for this particular gear. So common it is the pressure line, and the angle which it is they are making, okay, between the common tangent and the pressure line, that is nothing but the, it is known as the pressure angle. And it's a very important thing in case of gear designing also. Okay, So how we can define pressure angle, which is generally denoted by phi, is the angle between the pressure line and the common tangent to the pitch circles. Okay. Also, this pressure angle is sometimes known as the angle of obliquity. Okay. We have got some standard values for this pressure angle while designing gears. There are like 20-degree pressure angle, 25-degree pressure angle, and all. You will come across like that. Okay. And previously, 14.5 degree or that particular pressure angle was also used. But nowadays, this 14.5-degree standard pressure angle, nowadays it has been kind of absolute. So in most of the cases you will find come across like 20-degree pressure angle, 25-degree pressure angle, and all. Okay. And actually in another just important thing that we are discussing, so this is, see, if you look at this particular circle. Okay. So the, not the H one, that is the solid one. Okay. The solid one is, it is the base circle. Okay. And with respect to, we generally design the or construct this particular gear profile from the base circle, and after that some additional clearance is generally given. Okay. Which gives you the root circle or the dead random circle. Okay. So other thing already we have discussed in the previous case, what is the base circle, pitch circle, addendum circle, dead random circle, etc. And this is known as the central distance between the two gears, that is center to center from for both the gears, it is nothing but known as the center distance or central distance. Okay. So with this, basically we'll stop here for today, and if you have any question you can ask. So in the next class we'll be discussing about the different forms of teeth. Okay. The involute profile, cycloidal profile, etc. This part of contact, arc of contact, etc. And then we'll discuss about the different contact ratio, that is which gives you the number of pairs of teeth which will be in contact. Then we'll discuss something about interference, what is interference and all, how it can be avoided, what is the minimum number of teeth that will be required and all. Okay. And that kind of some problems we'll be solving. Okay. So with this we'll stop here for today. If you have any question you can ask, or if you have understood you can just let me know. Okay, seems like no question is there. I believe all of you have understood. So thank you everyone for joining to this class. I'm stopping the meeting.